Hi everyone, welcome to my channel. Today we will explore the various unmanned space programs launched by organizations around the globe. These programs, arranged by their launch dates, include orbiters, programs designed to explore different planets, and spacecrafts intended to venture into the vastness of space beyond our solar system. Let's start the video. The Soviet Sputnik program, launched in the late 1950s, revolutionized space exploration with its pioneering missions. Sputnik 1, launched on October 14, 1957, became the first artificial satellite to orbit Earth, demonstrating Soviet technological prowess and sparking the beginning of the space race. Sputnik 2 followed on November 3, 1957, carrying the first living being into space, a dog named Laika, intended not to return, whose presence provided crucial data despite the spacecraft's overheating. Sputnik 3 launched on May 15, 1958, advanced scientific knowledge with studies on cosmic rays and Earth's magnetic field. These achievements catapulted the Soviet Union to the forefront of space exploration, prompting significant technological and geological ramifications that continue to influence the space exploration today. The Luna program, initiated by the Soviet Union, marked a series of pioneering missions in space exploration during the 1950s and 1960s. Luna 1 launched on January 2, 1959, a historic mission as the first spacecraft to venture into the vicinity of the Moon. On January 4, 1959, Luna 1 passed within approximately 5,000 to 6,000 kilometers of the Moon's surface, marking the closest approach achieved by any spacecraft at that time. Despite missing its intended impact on the lunar surface due to a miscalculation in velocity, Luna 1 became the first human-made object to enter orbit around the Sun, where it continued to orbit to this day. The mission provided valuable scientific data, including measurements of cosmic rays and solar wind outside Earth's magnetosphere, contributing significantly to our understanding of space beyond our planet's immediate vicinity. Luna 1's trajectory and findings laid crucial groundwork for subsequent lunar missions and further exploration of the solar system. Luna 2, launched by the Soviet Union in 1959, became the first spacecraft to reach the Moon, successfully impacting its surface and marking a significant milestone in space exploration. Luna 3, launched on October 4, 1959, achieved another historic first by capturing and transmitting the first images of the far side of the Moon. These photographs offered humanity its initial glimpse of this hidden lunar hemisphere, providing valuable scientific insights into the Moon's surface composition and topography. Luna 4 to 8 contributed valuable data and experience in landing on the Moon, leading up to Luna 9, which achieved the first successful soft landing on the Moon. Luna 10, 11 and 12 were all lunar orbiters, in which Luna 10 plays the achievement of becoming the first spacecraft to orbit another celestial body. Luna 13, 15, 16, 17, 20, 21 and 24 were all successful soft landings on the Moon's surface and returned samples from the lunar terrain. Luna 14, 19 and 22 were successful lunar orbiters that sent valuable data and analysis of the lunar terrain for potential Soviet lunar landings. Luna 23 saw a tragic end when its lander tipped over, causing the premature end of the mission. Luna 25, launched in August 2023 by Russia, formerly the Soviet Union, was a planned lunar lander, although its onboard systems encountered issues resulting in a crash on the moon. Luna 25 provided crucial insights and lessons that will inform and enhance future lunar missions. The Pioneer missions represent a series of groundbreaking exploratory efforts that significantly advanced space exploration from the late 1950s through 1970s. Early attempts with Pioneer 0, 1 and 2, 1950 to 1959, aimed to explore the moon. Though these missions faced setbacks due to launch failures and trajectory errors, they provide a crucial experience and data that inform subsequent missions. Pioneer 3 and 4, 1950 to 1959, were designed for lunar exploration, with Pioneer 4 achieving success as the first US spacecraft to escape Earth's gravity and enter solar orbit, providing valuable insights into the moon and solar radiation. Moving beyond lunar missions, Pioneer 5 was launched to study interplanetary space between Earth and Venus. It yielded important data on solar radiation, cosmic rays, and the interplanetary magnetic field, bridging early lunar exploration and future planetary missions. The series continued with Pioneer 6, 7, 8, and 9, 1965 to 1998, which were solar orbiting satellites that offered continuous monitoring of solar activity. These missions enhanced understanding of solar wind, cosmic rays, and interplanetary magnetic fields, with some spacecraft transmitting valuable data for decades. Pioneer 10 and the Pioneer 11 marked a significant milestones by being the first spacecraft to traverse the asteroid belt and fly by the outer planets. Pioneer 10 provided the first close-up images of Jupiter and continued to send data from the outer solar system, becoming the first man-made object to travel beyond Pluto's orbit. Pioneer 11 followed with additional data on Jupiter before achieving the first flyby of Saturn, capturing close-up images and detailed information on its rings, magnetosphere, and the moon Titan. These missions expanded knowledge of the outer planets and their environments. The exploration of Venus was notably advanced by Pioneer 12 and 13. In 1978, Pioneer 12, Pioneer Venus Orbiter, conducted extensive studies of Venus, especially Venus's atmosphere, surface, and solar wind interactions, while Pioneer 13, Pioneer Venus Multiprobe, deployed probes into the atmosphere, providing detailed data on its composition and structure. Following their planetary encounters, Pioneer 10 and 11 continued to explore the heliosphere, offering valuable insights into the solar wind and cosmic rays in the outer solar system. Collectively, the Pioneer missions laid the foundation for future space exploration, significantly enhancing our understanding of the moon, interplanetary space, and the outer planets. Mariner 1 and 2, launched in 1962, were part of NASA's pioneering efforts to explore Venus. Mariner 1 was destroyed shortly after liftoff due to a rocket malfunction.
We're not on trajectory.
This is range safety. Stand by. Destruct command. Repeat, destruct command.
This will apparently blew up.
In contrast, Mariner 2 successfully completed its mission, becoming the first spacecraft to fly by another planet. It provided critical data on the solar wind and Venus's atmosphere, revealing the planet's extremely hot surface under thick clouds, despite not having a camera on board. Mariners 3 and 4, launched in 1964, were intended for Mars flybys. Mariner 3 failed to reach Mars because its shroud failed to open. However, Mariner 4 succeeded in its mission. Capturing the first close-up images of Mars' surface. These images revealed a cratered landscape, significantly enhancing our understanding of Martian geology and atmosphere. Mariner 5, launched on 1967, conducted a successful flyby of Venus, studying its atmosphere with ultraviolet light and radio waves. The mission advanced knowledge of Venusian atmospheric conditions and solar interactions. Following this, Mariner 6 and 7, launched in 1969, carried out successful flybys of Mars, capturing hundreds of images and performing detailed studies of the Martian atmosphere and surface, greatly expanding our knowledge of Mars's characteristics. Mariner 8 and 9, launched in 1971, had different fates. Mariner 8 was lost due to a launch vehicle failure, while Mariner 9 became the first spacecraft to orbit Mars. It conducted extensive mapping of the Martian surface and captured the first detailed images of Mars's moons Phobos and Deimos. These achievements were pivotal in mapping Mars and enhancing our understanding of its geology and moons. Finally, Mariner 10, launched in 1973, utilized a gravity assist from Venus to reach Mercury, making it the first spacecraft to visit 2 planets. It provided the first close-up images of Mercury's surface, significantly expanding our knowledge of the planet's features and conditions. The Mariner program thus laid the foundation for future interplanetary exploration, greatly advancing our understanding of the solar system. Giotto, named after the Italian painter Giotto di Bondone, was a pioneering mission by the European Space Agency (ESA) to study Halley's Comet and its environment. Launched on July 2, 1985, Giotto became the first spacecraft to encounter and study a comet close-up, providing invaluable data that revolutionized our understanding of these icy celestial bodies. Equipped with a suite of scientific instruments, Giotto's key instruments included camera, spectrometers, and particle detectors. This instrument enabled the spacecraft to capture detailed images of Halley's Comet, analyze its composition, and study the dynamics of its coma, the comet's atmosphere, and tail. Giotto made its historic close-up approach to Halley's Comet on March 13, 1985, passing within 596 kilometers (370 miles) of the comet's nucleus. Despite being battered by dust particles, with some even piercing the spacecraft, Giotto continued to transmit data back to Earth, providing unprecedented insights into the comet's composition and structure. The mission revealed that Halley's Comet is primarily composed of volatile ices, dust, and organic compounds. Giotto's observation also confirmed the existence of nucleus beneath the comet's coma and detected complex molecules like cyanogen and water vapor in the comet's atmosphere. Giotto's success marked a significant milestone in comet exploration, demonstrating the feasibility of close flybys and paving the way for future missions to study other comets and celestial bodies. The spacecraft's findings contributed to our understanding of the early solar system's formation and the role comets may have played in delivering water and organic material to Earth. Galileo was a pioneering mission by NASA to study Jupiter and its moons. Launched on October 18, 1989, aboard the space shuttle Atlantis, named after the Italian astronomer Galileo Galilei, the mission aimed to explore Jupiter and its diverse moons in detail, providing unprecedented insights into the largest planet in our solar system and its complex moon systems. Equipped with a sophisticated suite of scientific instruments including cameras, spectrometers, and particle detectors, Galileo conducted extensive observation of Jupiter's atmosphere, magnetosphere, and its diverse moon systems. The spacecraft's primary instruments include solid-state imaging (SSI) camera, near-infrared mapping spectrometer (NIMS), ultraviolet spectrometer (UVS), and plasma wave spectrometer (PWS). This instrument enabled Galileo to study the composition, structure, and dynamics of Jupiter's atmosphere and magnetosphere in great detail. One of Galileo's most significant achievements was its close-up observations of Jupiter's 4 largest moons: Io, Europa, Ganymede, and Callisto. The mission discovered evidence of subsurface oceans on Europa and Ganymede, suggesting potential habitats for extraterrestrial life. Galileo's observation of Io revealed active volcanoes and dramatic volcanic plumes, highlighting the moon's dynamic geology. Throughout its mission, Galileo made multiple flybys of Jupiter and its moons, captured detailed images and data that revolutionized our understanding of the gas giant and its satellite system. The spacecraft also deployed a probe known as the Galileo probe, which descended into Jupiter's atmosphere in December 1995, transmitted valuable data on the planet's composition and atmospheric conditions. Galileo's mission concluded in September 2003 when the spacecraft was deliberately crashed into Jupiter's atmosphere to avoid contamination of Europa or other potential habitable moons. The mission's legacy includes a wealth of scientific discoveries and data that continues to shape our understanding of Jupiter, its moons, and planetary systems beyond Earth. Galileo's pioneering spirit and scientific achievements paved the way for future exploration and outer solar system and inspired new missions to explore distant worlds. MAVEN, Mars Atmosphere and Volatile Evolution. MAVEN, launched by NASA on March 18, 2013, is a mission dedicated to studying Mars's upper atmosphere, climate history, and interactions with the solar wind. Arriving at Mars in September 2014, MAVEN's primary goal is to understand how Mars lost its atmosphere and water over billions of years, transforming from a potentially habitable planet into the dry, cold world we see today. Equipped with a suite of scientific instruments, MAVEN's key tools include a Particles and Fields Package (PFP), which measures solar wind and ionospheric particles, and a Remote Sensing Package (RS), which analyzes ultraviolet light and solar radiation interactions with Mars's atmosphere. These instruments allow MAVEN to study atmospheric escape processes, measure the current rate of atmospheric loss, and investigate the role of solar wind and solar radiation in stripping away Mars's atmosphere over time. One of MAVEN's significant findings is its discovery of widespread auroras on Mars, which are caused by interactions between charged particles from the Sun and the planet's upper atmosphere. These auroras provide insights into Mars's magnetic fields and its interactions with the solar wind, helping scientists understand the planet's past climates and atmospheric evolution. Mangalyaan, also known as Mars Orbiter Mission, is India's first interplanetary mission launched by the Indian Space Research Organisation (ISRO) on November 5, 2013. Its primary objective was to demonstrate India's technological capabilities in interplanetary exploration and study Mars' surface, morphology, atmosphere, and mineralogy. Mangalyaan successfully entered orbit on September 24, 2014, making India the first Asian country to reach Mars and the fourth space agency in the world to do so. Equipped with 5 scientific instruments, Mangalyaan aimed to study Mars' surface features, mineral composition, and search for methane in the Martian atmosphere. The spacecraft's payloads include the Mars Color Camera (MCC), Thermal Infrared Imaging Spectrometer (TIS), Methane Sensor for Mars (MSM), Lyman Alpha Photometer (LAP), and Mars Exospheric Neutral Composition Analyzer (MENCA). These instruments allow Mangalyaan to conduct comprehensive scientific observations from orbit. The mission achieved its primary objectives of orbit insertion, scientific exploration, and technology demonstration, surpassing expectations with its precision and cost effectiveness. The spacecraft's findings have contributed significantly to understanding Mars' atmosphere and surface processes, including detailed mapping of the planet's surface features, monitoring dust storms, and studying the behavior of water vapor and other gases in the Martian atmosphere. Mangalyaan's success has bolstered India's space exploration capabilities and positioned ISRO as a key player in the global space community, paving the way for future ambitious missions to explore the mysteries of our solar system and beyond. ExoMars Trace Gas Orbiter (TGO), a joint mission of the European Space Agency and Roscosmos, Russian Space Agency, launched on March 14, 2016 with the primary goal of studying Mars' atmosphere and searching for traces of gases that could be linked to biological or geological activity. Equipped with a suite of scientific instruments, TGO's key objectives include detecting and mapping trace gases in Mars' atmosphere, particularly methane, which could indicate active geological processes or microbial life. The spacecraft's instruments include the Nadir and Occlusion for Mars Discovery, Nomad Spectrometer, and Atmospheric Chemistry Suite (ACS), and the CASSIS Color and Stereo Surface Imaging System. These tools enable TGO to analyze the composition of Mars' atmosphere with unprecedented sensitivity and details. TGO successfully entered orbit around Mars on October 19, 2016 and began its scientific mission to study the planet's atmosphere in depth. One of its primary tasks is to create detailed maps of methane and other trace gases across Mars, helping scientists understand their sources, distribution, and seasonal variations. This data is crucial for unraveling the mysteries of Mars' atmosphere dynamics and its potential for past or present habitability. In addition to its atmospheric studies, TGO serves as a communication relay for surface missions including the ExoMars rover, Rosalind Franklin, planned for launch in 2023. Its advanced communication capabilities enable real-time data transmission between the rover and Earth, enhancing the rover's operational efficiency and scientific output. ExoMars TGO's mission includes to provide valuable insights into Mars' atmospheric evolution, climate history, and potential for life. By combining its atmospheric observations with future surface exploration missions, TGO plays a pivotal role in ESA's broader goal for understanding Mars' atmosphere and preparing for future human exploration of the red planet. The Emirates Mars mission, also known as the Hope Mars mission, represents United Arab Emirates' UAE's first interplanetary mission. Launched on July 19, 2020 by the Mohammed bin Rashid Space Center (MBRSC) in collaboration with several international partners. Its primary objective is to study Mars' atmosphere, climate dynamics, and weather patterns over an entire Martian year, approximately 2 Earth years. Equipped with 3 scientific instruments, HOPE aims to provide a comprehensive understanding of Mars's atmosphere, including its interactions with solar radiations and the escape of hydrogen and oxygen into space. The spacecraft's instruments include the Emirates Exploration Imager EXI, the Emirates Mars Ultraviolet Spectrometer EMUS, and the Emirates Mars Infrared Spectrometer EMIRS. These tools enable HOPE to study the planet's atmosphere across different altitudes and times of day, providing valuable data on Mars's daily and seasonal weather patterns. HOPE successfully entered Mars orbit on February 9, 2021, positioning itself in a unique elliptical orbit that allows it to observe the planet's atmosphere from pole to pole. This orbit provides unprecedented global coverage, allowing the mission to monitor atmospheric changes, dust storms, and temperature variations throughout Mars's year-long season. The mission's significant goals include generating a global map of Mars's atmosphere, investigating the mechanism behind the atmospheric escape, and studying the influence of Mars's climate on a loss of hydrogen and oxygen to space. HOPE's observation contribute to our understanding of Mars's evolution from a warm, wet planet billions of years ago to the cold, dry desert world we see today. Beyond scientific research, the HOPE Mars mission aims to inspire a new generation of scientists and engineers in the UAE and the broader Arab world, fostering innovation and technological advancements in space exploration. Juno, a NASA spacecraft launched on August 5, 2011, aboard an Atlas V rocket, represents a landmark mission dedicated to exploring Jupiter, the largest planet in our solar system. Named after the Roman goddess Juno, the mission's primary objectives are to investigate Jupiter's atmosphere, magnetic field, and gravitational field, and to provide insights into the planet's formation and evolution. Equipped with a suite of scientific instruments, Juno's key instruments include the Microwave Radiometer MWR, JunoCam, Jovian Infrared Auroral Mapper, GIRAM, Ultraviolet Imaging Spectrometer UVS, and Gravity Science Instrument GSI. These instruments enable Juno to study Jupiter's deep atmospheres, measure its water content, map its magnetic and gravitational fields, and capture high-resolution images of the planet's cloud tops and polar regions. Juno's unique polar orbit allows it to make close flyby over Jupiter cloud tops, providing unprecedented views and data on the planet's dynamic atmosphere and storm systems, including its famous Great Red Spot. The spacecraft's JunoCam has engaged the public by providing stunning images of Jupiter, inviting enthusiasts worldwide to participate in selecting targets for observation. One of Juno's primary spacecraft goals is to understand Jupiter's interior structure, including whether the planet has a solid core and how deep its atmosphere zones extend. By measuring Jupiter's gravitational and magnetic fields with high precision, Juno aims to reveal clues about the planet's origins and the process driving its powerful magnetic field. Juno's mission is also significant for its role in planetary protection and understanding the radiation environment around Jupiter is crucial for planning future missions to Jupiter's moons, particularly Europa and Ganymede, which may harbor subsurface oceans and potential habitats for life. Juno continues to operate and deliver groundbreaking scientific discoveries, offering new insights into Jupiter's atmosphere, magnetosphere, and planetary systems. Cassini-Huygens, a joint NASA, ESA, and ASI mission, launched on October 15, 1997, aimed to explore the Saturnian system in unprecedented detail. Named after the astronomers Giovanni Cassini and Christian Huygens. The mission comprised the Cassini orbiter and the Huygens probe. The orbiter focusing on Saturn and its moons, and the probe designed to study Titan, Saturn's largest moon. Equipped with a diverse array of scientific instruments, Cassini's instruments include cameras, spectrometers, radar, and particle detectors, among others. This instrument allowed Cassini to conduct extensive studies of Saturn's atmosphere, magnetosphere, rings, and diverse moon systems. Cassini's key discoveries included detailed observation of Saturn's rings, revealing their complex structure, dynamics, and interactions with Saturn's moons. The spacecraft also provided insights into Saturn's atmosphere, including its weather patterns, storms, and seasonal changes. Near Shoemaker. Near Shoemaker, also known as Near-Earth Asteroid Rendezvous (NEAR), was a NASA spacecraft launched on February 17, 1996, with the primary objective of studying asteroids, specifically 433 Eros. It was the first spacecraft to orbit and land on an asteroid, marking a significant milestone in asteroid exploration and our understanding of these rocky bodies. Equipped with a suite of scientific instruments, NEAR's key instruments included multispectral imager, a laser rangefinder, a magnetometer, a gamma ray spectrometer. These instruments enable NEAR to study 433 Eros' surface and composition, topography, magnetic field, and gravity, providing insights into asteroids' origin and evolution. NEAR arrived at 433 Eros on February 14, 2000, becoming the first spacecraft to orbit an asteroid. Over the course of its mission, NEAR conducted extensive observations from orbit, marking the asteroid's surface in detail and capturing over 160,000 images. These images reveal a complex landscape of craters, rocks, and surface features that provide clues to the asteroid's geological history. On February 12, 2001, NEAR made history again by becoming the first spacecraft to land on an asteroid's surface. The landing was not originally planned, but NEAR's controllers successfully maneuvered the spacecraft to touch down gently on the surface of 433 Eros, where it continued to transmit data for several days before succumbing to the harsh conditions. NEAR's mission yielded numerous scientific discoveries, including insights into the composition and structure of asteroids, their geological processes, and their potential as remnants of the early solar system. The mission also provided valuable data for understanding the formation and evolution of asteroids and their potential hazards to Earth. NEAR Shoemaker's success demonstrated the feasibility and importance of exploring asteroids up close, influencing future asteroid missions such as NASA's OSIRIS-REx and JAXA's Hayabusa missions. Stardust was a NASA spacecraft launched on February 7, 1999, with the primary mission of collecting samples and dust and cometary particles from comet Voyage 2 and returning them to Earth for analysis. The spacecraft also collected interstellar dust samples during its mission, contributing valuable insights into the origins of our solar system and life's building blocks. Equipped with a unique collector called the aerogel grid, Stardust traveled through the coma of Comet Wild 2 on January 2, 2004, capturing particles from Comet's dusty halo. The spacecraft returned to Earth on January 15, 2006, releasing its sample return capsule, which landed in the Utah desert. Scientists retrieved and analyzed and captured particles discovering organic compounds and minerals that provided clues about the conditions in the early solar system. Hayabusa. Hayabusa and Hayabusa 2 are pioneering missions led by the Japan Aerospace Exploration Agency JAXA, dedicated to exploring asteroids and returning samples to Earth. Hayabusa launched on May 9, 2003, aimed to study asteroid 25143 Itokawa. Despite encountering technical challenges and malfunctions, Hayabusa successfully reached Itokawa in September 2005. The spacecraft conducted close-up observations and attempted to collect surface samples using a sampling device. Despite difficulties during the sample collection, Hayabusa managed to return to Earth in June 2010, delivering a small amount of asteroid material. Hayabusa 2, launched on December 3, 2014, continued Japan's asteroid exploration efforts with the primary mission to study asteroid 162173 Ryugu. Arriving at Ryugu in June 2018, after a 4-year journey, Hayabusa deployed multiple landers and rovers to explore the asteroid surface. In February 2009, the mission achieved a historic milestone by successfully collecting surface samples from Ryugu using a projectile system called Small Carry-On Impactor SCI. Hayabusa 2 departed Ryugu in November 2019 and returned to Earth on December 6, 2020. OSIRIS-REx. OSIRIS-REx origins, spectral interpretation, resource identification, security, regolith explorer is a NASA spacecraft mission designed to study asteroid 101955 Bennu, a near-Earth asteroid, and return a sample of its regolith surface material to Earth for detailed analysis. Launched on September 8, 2016 from Cape Canaveral Air Force Station, OSIRIS-REx embarked on a 7-year journey to rendezvous with Bennu. Arriving at Bennu in December 2018, OSIRIS-REx conducted a comprehensive survey of the asteroid surface and environment using a suite of scientific instruments, including cameras, spectrometers, and laser altimeter. The spacecraft identified potential sample collection sites and studied Bennu's composition, shape, rotation, and geological features in detail. In October 2020, OSIRIS-REx successfully completed its touch and go TAG maneuver to the asteroid surface and briefly touched down to collect samples using a robotic arm called TGASM, Touch and Go Sample Acquisition Mechanism. The mission exceeded expectations by collecting a substantial amount of regolith, which was stored in a sample return capsule for the journey back to Earth. OSIRIS-REx departed Bennu in May 2021. And successfully landed back on Earth on September 24, 2023, delivering its precious cargo of asteroid samples. The mission aims to provide new insights into the early solar system's formation, the distribution of water and organic molecules in asteroids, and the potential hazards posed by near-Earth asteroids. OSIRIS-REx's achievement have advanced our understanding of asteroid dynamics and impact mitigation strategies, demonstrating NASA's commitment to planetary defense and expanding our knowledge of planetary science through sample return missions. The Double Asteroid Redirection Test (DART) is a NASA mission designed to test asteroid deflection technology. Launched on November 24, 2021, DART's primary objective is to demonstrate the capability to redirect the trajectory of an asteroid by colliding with a small moonlet orbiting in a binary asteroid, Didymos. NASA's Double Asteroid Redirection Test DART mission achieved a major milestone on September 26, 2022, when its spacecraft successfully impacted the asteroid moonlet Dimorphos. The spacecraft aimed to demonstrate asteroid deflection technology by altering Dimorphos' orbit around the large asteroid Didymos. The impact caused a significant change, shortening Dimorphos' orbit period around 32 minutes and 42 seconds, reducing it to 11 hours 22 minutes.
Three, two, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
The probe's primary objective is to enhance our understanding of the solar processes that drive space weather phenomena. By studying the Sun's corona up close, the Parker Solar Probe aims to provide insights into the solar wind dynamics, magnetic fields, and energetic particle emissions. This knowledge could improve our ability to forecast solar storms and their potential impacts on Earth's technology and astronauts during space missions. NASA's Parker Solar Probe orbits as close as 9.86 solar radii from the center of the Sun, approximately 3.9 million miles, 6.2 million kilometers away. During its closest approach, the probe travels at speeds reaching up to 690,000 km per hour, 430,000 miles per hour, which is about 0.064% of the speed of light, making it the fastest man-made object. Equipped with advanced instruments including cameras, spectrometers, and particle detectors, the mission aims to study the Sun's outer corona and gather crucial data on solar activity, including lunar exploration. The Parker Solar Probe's heat shield, called the Thermal Protection System (TPS), is made of two panels of reinforced carbon-to-carbon composite with a carbon foam core and a special white coating. This innovative design enables the TPS to withstand temperatures exceeding 1400 degrees Celsius, 2552 degrees Fahrenheit. At its closest approach, known as perihelion, while keeping the spacecraft's instruments at a comfortable operating temperature, this technology allows the probe to endure the extreme conditions near the Sun and gather unprecedented data on the Sun's environment. The Solar and Heliospheric Observatory (SOHO) is a collaborative mission between NASA and the European Space Agency (ESA). Launched on December 2, 1995, SOHO's primary objective is to study the Sun, particularly its outer atmosphere corona, and the solar wind, which extends far beyond the Sun into interplanetary space. Equipped with a suite of instruments including telescopes, spectrometers, and detectors, SOHO observes the Sun continuously from a vantage point between the Earth and the Sun known as Lagrange Point 1. This unique position allows SOHO to monitor solar phenomena such as solar flares, coronal mass ejections, CMEs, and sunspots, providing valuable data for solar and heliophysics research. SOHO has made numerous discoveries since its launch, including insights into the structure and dynamics of the solar atmosphere, variations of the solar cycle, and the impact of solar activity on space weather. Its observations have significantly contributed to our understanding of solar physics and its influence on Earth environment, satellite communication, and astronaut safety. In addition to its scientific research, SOHO plays a crucial role in space weather forecasting by providing real-time data on solar activity. Its observations help forecasters predict geomagnetic storms and other space weather events that can affect technological infrastructure and space missions. The MESSENGER Mercury Surface Space Environment Geochemistry and Ranging mission, launched by NASA in 2004, marked the first spacecraft to orbit Mercury, significantly advancing our understanding of the innermost planet. After a 6.5-year journey involving flybys of Earth, Venus, and Mercury to adjust its trajectory, MESSENGER entered Mercury's orbit in March 2011. Over its 4-year orbital mission, MESSENGER collected comprehensive data on Mercury's surface, composition, magnetic field, and exosphere. The mission revealed the presence of water ice and organic compounds in permanently shadowed craters, and evidence of recent geological activity, providing insights into the planet's formation and evolution. MESSENGER's suite of scientific instruments enable detailed mapping and analysis of Mercury's surface and environment. The spacecraft's findings included a surprising abundance of volatile elements like sulfur and potassium, suggesting that Mercury's formation and history were more complex than previously thought. The high-resolution image revealed surface features such as impact craters, tectonic landforms, and volcanic plains, while its magnetometer provided critical data on Mercury's magnetic field, indicating that it is actively generated by a molten outer core. MESSENGER's mission concluded with a controlled impact on Mercury's surface in April 2015. But its legacy continues with the vast amount of data that has reshaped scientific perspectives on the smallest planet in our solar system. The BepiColombo mission, a collaborative effort between the European Space Agency and the Japan Aerospace Exploration Agency (JAXA), was launched on October 2018 to study Mercury in unprecedented detail. Named after the Italian mathematician Giuseppe BepiColombo, the mission consisted of two spacecraft, ESA's Mercury Planetary Orbiter (MPO) and JAXA's Mercury Magnetospheric Orbiter (MMO), also known as MEO. BepiColombo embarked on a 7-year journey involving multiple gravity assist flybys of Earth, Venus, and Mercury to slow down and adjust its trajectory. It achieved a significant milestone in October 1, 2021, with its first flyby of Mercury, sending back several images of the planet. Several more planetary flybys will precisely steer BepiColombo into orbit around Mercury in December 2025. Once in orbit, the two spacecraft will separate and begin their individual scientific missions. The MPO will map Mercury's surface in high resolution, analyze its composition, and study its exosphere and interior structure, while the MMO will focus on Mercury's magnetic field, magnetosphere, and interaction with the solar wind. BepiColombo aims to answer key questions about Mercury's formation and evolution, building on discoveries made by the Messenger mission and offering new insights into the innermost planet in our solar system. The mission's comprehensive suite of scientific instruments and dual orbiter approach will provide an unprecedented level of detail, scientifically enhancing our understanding of Mercury's geology, magnetism, and surface processes. Akatsuki, also known as Venus Climate Orbiter, is a Japanese spacecraft launched by the Japanese Aerospace Exploration Agency (JAXA) in 2010 with the primary goal of studying Venus's atmosphere and climate. Originally launched on May 20, 2010, Akatsuki encountered a setback in its attempt to enter Venus's orbit due to a malfunction in its propulsion system. However, after adjustments and a 5-year journey through space, Akatsuki successfully entered orbit around Venus on December 7, 2015, marking a significant achievement in planetary exploration. Equipped with a suite of scientific instruments including infrared and ultraviolet images as well as radio occultation experiment, Akatsuki began its mission to study the dynamics and inhospitable environment of Venus. Akatsuki began its mission to study the dynamic and inhospitable environment of Venus. The spacecraft focused on observing the planet's atmospheric dynamics, including its superrotation phenomenon, where the atmosphere rotates much faster than the planet itself. Akatsuki's observations provided detailed insights into Venus's cloud formations, atmospheric composition, and weather patterns, contributing to our understanding of the planet's extreme climate conditions. One of Akatsuki's key achievements was its detections of atmospheric wave patterns and variations in sulfur dioxide levels, which are indicative of active volcanic processes in Venus. The spacecraft's infrared images also reveal thermal emissions from Venus's surface, helping scientists to map surface temperatures and identify potential geological hotspots. Mars Global Surveyor (MGS), launched by NASA in November 1996, was a pioneering mission designed to comprehensively study Mars' surface, atmosphere, and climate. The spacecraft arrived on Mars in September 1997 and operated for more than 9 years, making it one of the longest operating missions to the Red Planet. Equipped with a suite of advanced scientific instruments, MGS conducted extensive global mapping of Mars. Its primary camera, the Mars Orbiter Camera (MOC), captured high-resolution images of the Martian surface, revealing details as small as a few meters across. These images provided unprecedented insights into Mars' geology, identifying features such as impact craters, volcanoes, ancient rivers, and polar ice caps. MGS also used its laser altimeter to map Martian topography with high precision, creating detailed elevation models. Mars Odyssey, launched by NASA in April 2001, has been a pivotal mission in the exploration of Mars, focusing on studying the planet's climate, geology, and radiation environment.
We have ignition and liftoff of a Delta II rocket carrying NASA on an odyssey back to Mars.
Arriving at Mars in October 2001, Mars Odyssey has since become one of the longest operating spacecraft in orbit around the Red Planet, surpassing its planned mission duration multiple times over. Equipped with a suite of scientific instruments, Mars Odyssey's primary goals included mapping Mars' surface composition, detecting water ice and materials, and studying the planet's thermal and radiation environment. The spacecraft's Thermal Emission Image System. The spacecraft's thermal emission imaging system theme is providing detailed thermal maps of Mars' surface, revealing variation in temperature that help identify regions with different geological features including volcanic activity, impact craters, and ancient river valleys. Odyssey's Gamma Ray Spectrometer GRS detected hydrogen concentration beneath the Martian surface, suggesting the presence of water ice in the polar regions and at lower altitudes. One of the mission's notable achievements was its role in identifying potential landing sites for future Mars missions, including the Phoenix lander and Mars Science Laboratory Curiosity rover. Odyssey's precise mapping of Mars' terrain and its ability to detect subsurface water ice made it instrumental in selecting scientifically interesting and safe landing locations. I hope this video on the evolution of the unmanned spacecrafts and probes was interesting. We'll meet in the next video with more interesting information. Take care, bye.